All right, so I have a very basic or a very simple question for ChatGPT. The question is, what is the current time? So let's see what ChatGPT answers. What is the current time? And ChatGPT says that it doesn't have real-time capabilities. That means it can't check the current time. That's an expected answer, right? I also asked Claude a similar question. I asked what is the temperature or what is the current temperature in Bengaluru, and Claude responded saying that it doesn't have access to real-time weather data or the ability to check current conditions. It's an answer that I was expecting. Now, there is a pattern here, right? You see that both these powerful LLMs, that is GPT-4o and Sonnet, were not able to answer a real-time question simply because it doesn't have, or they don't have access to real-time information, right? Now, that's the problem statement. All right, now that we have established the problem statement, let's see if an agent can actually solve this particular problem. That is, if an agent can essentially get the current time and temperature of a given city. I've written a basic agent, and let's see if that works. The agent is already running. It's asking me if it can, or how it can assist me today. So I'm going to ask the question, what is the current time and temperature in Bengaluru? The agent has started working. It is printing a few statements, as you can see on the screen. We'll wait for the final response. All right, so we have the final response from the agent. The current time is 9:17 a.m. and the temperature is 26.53 degrees with scattered clouds in Bengaluru. Wonderful, isn't it? This is actual data right now. Now, before we understand how this particular agent was written, I want to spend a few minutes on the building blocks of an agent. Let me pull up the PPT. An agent essentially comprises of three primary components. First is the model, second is the tool, and third is the reasoning loop. The model here refers to the large language model, which is at the core of the AI agent. This is the foundation of the agent's intelligence and capabilities. It gives the agent the capability to process complex instructions. Second is the tool. Tools are specific functions or capabilities that the AI agent can use to interact with its environment to perform certain tasks. For example, those tasks could be, calling an API, looking up on Google, or looking up on a database, talking to a file system, or in fact running or executing code that is generated by an LLM. Basically, it enhances or extends the capabilities of the LLM. The third one is the reasoning loop. Now, this is the most important part of an agent. Here, it's essentially an iterative decision-making process that allows the agent to make decisions, solve problems, and accomplish tasks. In the context of our basic agent, let's see how the three components work together. So the user is asking a very simple question. What is the current time and temperature in London? The agent receives that particular query. The agent then sends that particular query to an LLM. The LLM identifies the tool because the LLM has a list of tools that it can identify from. The LLM, in the context of the question, identifies the tool first. It has identifies tool number one, which is the time tool to be executed. The agent takes the response from the LLM, executes that particular method, the time tool method, takes the response from the time tool that it has received from that particular method, and sends the context, which is the response from the tool and the original query, back to the LLM. Now this time, the LLM knows that it already has a time. It needs to identify the next tool, and it identifies the next tool, which is the weather tool. The agent once again takes the output that it has received from the weather tool and executes the weather tool, and then combining it with the context that it has, which is the response from the LLM, which is the response from the weather tool. Again, with combining it with the original query, sends the information back to the LLM. The LLM now identifies that it has information about the time as well as the other, and it decides to return the response back to the user. It is not going to essentially look for more tools. The action here is that the response that was generated by the LLM and the tools is returned back to the user. All right, you'll understand this once I show you the actual code. All right, let's do a quick walkthrough of the code. The only library that we have installed is the request library. That's the only third-party library that we need. All the other libraries that we'll use in the code, you'll see in a moment, is built into Python. The first thing that we'll create is a list of tools. For that, we'll have to create an abstract class or an interface or a base class called tool by using the abstract base class and the abstract method decorator built into Python. Essentially, we need this so that all the tools that we create have the same implementation. That means they need to have the same methods, name, description, and use. Let me quickly walk you guys through the time tool. It is inheriting the tool base class. It has the name, time tool, and it has a description. And this is very, very important. The level of detailing here can improve the quality of the responses when the LLM identifies the tool that it needs to execute. For example, in this case, I am telling, or I've written that this particular tool provides the current time for a given city's time zone, like Asia, Kolkata, America, New York, etc. Remember, when the user queries, the user doesn't mention the time zone, the user only mentions the location, for example, Bangalore or London. The LLM, depending on this particular description, generates or comes up with the time zone for that particular location and then creates an argument of it so that it can be passed to the time tool. I'm going to show you guys that in a bit. Similarly, there is the weather tool, which has the same methods, name, description, and the use method is the implementation of that particular tool where we execute that particular tool. All right. I'm not going to spend a lot of time here. You guys can go through the code and see that for yourself. Let's just look at the all-important agent class. The agent class decorator has 3 attributes: tools, memory, max memory, very critical. The tools essentially will have the list of tools that we will add once the agent class is instantiated. The memory attribute is used to build context of the historical conversation, the conversation history. I'm going to show you guys that in a bit. The next method here that you see is JSON parser. You might not need this for GPT. The latest models have JSON response built in, but if you're using open source models, this particular parser method could help. We'll look at the process input method now. The process input method takes in the user input, which is basically the query, user's query. It is then appended to the memory attribute, which is a list, a conversation history, and it can only take in the last 10 items. This is the max memory that we have, sort of called out here. It can only take in only the last 10 items, that is user's input as well as the response from the LLM. It basically acts as conversation history, very good context for the LLM, and you will see why it is so important. The next one is we basically sort of collate all the tool descriptions of all the tools we have. In this case, we have 2 tools, but you could think of an agent which has several tools. We collate all the descriptions with the name as well as the description of that particular tool, and then we pass that as context, additional context, so that the LLM can pick the relevant tool depending on the query. All right. The next one is the response format. I want the response to be in a specific format. Some people usually use regex, not use a JSON response format like this, but I like to keep it clean so that we can easily interact with the responses of an LLM. Right now, let's look at the prompt. The prompt is simple. I'm passing the context. The context is the conversation history, so to speak. The next is the available tools, which is the tools description. Again, this has the name as well as the description of each and every tool that we have. In our case, there are 2 tools, time tool and the weather tool. And then the instructions to that particular, to the LLM. Here, this is a very simple instruction. As you can see, I'm asking the user to basically, based on the user's input and context, decide if you should use a tool or respond directly. Sometimes you might have to use multiple tools to solve user's input. You have to do that in a loop. And if you identify an action, respond with the tool name and the arguments for the tool, right? When you're working with an LLM in a loop, you need a way to come out of the loop. That means you need to come out of the loop and then return that response back to the user. How do you do that? One of the ways that I do that is basically to tell the response, or at least come up with a tool name called respond to user. And the argument here is the actual response of the LLM, the final response of the LLM. We also tell the LLM the response format that it needs to create. All right, this is our prompt. It's a very simple prompt, as you can see. We then send that particular prompt to the LLM. We query the LLM. Essentially, let me quickly show you the query LLM method. I'm using OpenAI here, OpenAI's latest model GPT-4o mini, and I have added that as the prompt, the prompt that we generated right here, and we are sending it to OpenAI. The OpenAI comes back with a response. We then append that response to memory. This is so that we build context to build the conversation history and use it as a context when we are sending the LLM the prompt. We then essentially parse that particular response so that we can easily identify the tool and the arguments. So we iterate over all the tools. We check if the identified tool or action by the LLM matches with any of the tools that we have. It does. If it does, we essentially run that particular tool by passing the arguments that the LLM has generated for us, right? After this is done, the LLM essentially, or the process input essentially returns a response that is generated by the LLM. The most important method is the run method, which is the all-important reasoning loop. Essentially here, we take in the user's input, we run it through a loop, meaning that we first send it to the process input method. We ask the LLM to identify the relevant tool for us, and we capture the response from the LLM after executing that particular tool. We check if the response is if the response has a respond to user. If it doesn't, we basically send the context, that is the response that we received from the LLM and the tool, back to the LLM as input again, and we do this until we get respond to user. All right. So let me quickly run this. The agent is still running. I'm going to ask it a new question. What is the temperature in New York? As you can see, now the LLM has identified it's the weather tool, and it has basically returned a response. The temperature in New York is currently at 21.47 degrees. Now, I was talking about the importance of context in the conversation history. Now, without me mentioning the name of the city, I will simply write time, and you will see that it will essentially identify that the time was for New York. It will identify the time zone and return the relevant time, or the current time in New York at this time. The current time in New York is 12:41 a.m. All right, so we learned how to create a basic agent using 3 components, that is the reasoning loop here, the tools here, and the LLM, which acts as the foundation for our agent. I hope this was easy. I hope this was useful. Please let me know in the comments if you want to see more videos like this. Thank you so much.